Hi class, let's take a look at problem 6. So once again, let me pinpoint to the actual notation, and I'm just going to use the same letters, meaning X, that I used in class, and let's actually evaluate this one. So as we evaluate the derivative using the definition, our f prime of x is equal to technically the limit as h approaches 0 of f of x plus h minus the values of f of x divided by the values of h. And this is going to be equivalent to the actual limit so we're looking at the actual limit as h approaches 0 of the values of cosine of x plus h minus the values of cosine of x over the values of h. Now, for this particular one, we're going to use an identity. I've put the identity technically here, and we have the top. So you're going to have cosine, technically cosine of the second value minus the sine of these two. So let me just write it up so that it's clear the identity that we're using. And in this case, let me do it in green. We technically have the cosine of x plus h is equal to the values of cosine of x and cosine of h minus the sine of x and sine of the values of h. So that's going to be the substitution for technically this value. And let me rewrite it. So we still have the limit. So we're looking at this is equivalent to the actual limit as h approaches 0 of, and we now have the values of cosine of x, cosine of h, minus the values of sine of x, sine of h, and then don't forget the minus the cosine of x, all over your h value. Now what I'm going to do is I'm just going to arrange the terms and technically separate the actual signs. We're going to be using an identity as well, actually two identities. But in this case, let me just rewrite it. This is going to be the limit as h approaches 0 of, and let me rewrite it as the cosine of x, cosine of h minus the cosine of x, technically minus the sine of x and the sine of h, and then all of it over h, and then I'm going to separate it. Now, let me explain why separated. You're technically going to be using identities, and the identities are with respect to the following limits, except that the limits in the actual expression have h's. But we're interested to see where the functions are actually approaching. So in this case, what I'm going to do is I'm going to separate the expression as technically two limits, and this is going to be equivalent to the actual limit as h approaches 0 of, and we technically have the cosine of x times, and I'm going to put it just the cosine of h minus 1 divided by h, and technically minus the limit as h approaches 0 of the values of sine of x times the values of the sine of h, technically over the values of h. And then technically, since we're taking the limit of h, in this case, your actual cosine of x and your sine of x represent constants. So you can technically take them out of the actual limit. And then we're going to be rewriting them as this is equivalent to the cosine of x times the actual limit as h approaches 0 times the values of cosine of h minus 1 divided by h, and then minus the sine of x times the limit as h approaches 0 of the values of sine of h over the values of h. And then we're going to be using the following identities. And let me write them in green. In this case, let me just put a comma. The actual limit as h approaches 0 of the values of cosine of h minus 1 divided by h actually represents this one. Except that in decimals, I'm actually using technically x's, and you can see that the limit is defined at 0. So for that particular one, we're going to have that this is equal to 0. And then the actual limit as h approaches 0 of the values of sine of h divided by h, this is equal to 1. And this is our first graph here, except that once again, in decimals, I'm using the values of x's, and they just represent identities. And then at this point, let me rewrite the entire expression. I'm just going to start from where we left off, f prime of x. So I'm just going to say that f prime of x, it's equal to the cosine of x times technically 0 minus the sine of x times the values of 1. And then technically this portion, in terms of the limit, it goes to 0. This portion, it happens to go to 1. And then for this particular problem, we're technically done. F prime of x is equal to negative sine of x. That's going to be our solution, our actual limit. And this one was a little bit messy, actually converges to just the negative sign for the actual values of cosine of x.